Awesome. So where is the numerator going when x approaches negative infinity?
Negative infinity.
Excellent. Where is the denominator going when x approaches negative infinity?
Negative infinity.
Good. So there is hope. Remember, there is no hope for a number over 0. There is no hope for this. But infinity over infinity or 0 over 0, there is hope. Okay. What do we do in these cases? Anyone remembers what was the procedure? What did we do? We factored out the degree. What is the degree of the numerator?
Just x.
Good. What is left in parentheses? This times this is 2x. What do I have here?
2 minus 3 over x.
Very good. And of course, we have the same thing here. X, and then 1 minus 5 over x. I'm happy to move this away from here. What is the limit?
Two.
Yes, because these are 0. How do I know? 3 divided by huge. This approaches 0. This approaches 0. So the limit is 2. There is no difference. The same thing is here. No matter what to do, you're going to have the same steps. What does this mean? So when the limit of a function, when x approaches negative infinity equals 2, means this. Y equals 2 is a horizontal asymptote. So something like this. This is not part of the graph. It cannot be a solid line. Y equals 2, which means the limit of the function when x approaches negative infinity, when x approaches negative infinity, the function values get closer and closer to 2. From above or from below. As x gets closer and closer to negative infinity, the function gets closer and closer to 2. As x approaches positive infinity, the function values get closer and closer to 2, maybe from above or maybe from below. It doesn't matter. I found something. I found something. So this is how we deal with the horizontal asymptotes. And the pertaining limit, of course. That's how the horizontal asymptote is discovered, by determining these limits. I have one more step. And you can say, these are way more difficult than the previous functions, the polynomials. Yes, they are. I also need to determine the limit here and here. And that will talk about vertical asymptotes. So I need to determine the limit as x approaches 5 from the left of the function and as x approaches 5 from the right of the function, because I don't know where the function is going here. It's undefined, but where it's going. It doesn't cross at 5. But is it going to positive infinity? Is it going to negative infinity? Is it going to positive infinity on both sides, negative infinity on both sides? I have no clue. So I need to determine the limit from the left of 5 and the limit from the right of 5. And then I exhausted everything here. Only now I can say, after that, I'm done. I can explore this and see what this is telling me about this. Okay, so let's find the limit. So we have the limit as x approaches 5 from the left, and the limit as x approaches 5 from the right. Of the function, of course. 2x minus 3 over x minus 5, 2x minus 3 over x minus 5. We're asked to find limits. Again, And again, the same thing. You thought you could leave the limits behind. No, it's not going to work. Okay, what is the first thing I need to identify? Exactly what we did here. Nothing different. I need to
You're just plugging it again, right?
plug it in. So 5 times 2 is 10. 10 minus 3 is a positive number. How much is 5 minus 5?
Well, 0. But
Good. No, we can never conclude that. Remember, a number,
sorry.
that's okay. Let's review this. It's very important. I can get negative infinity, I can get infinity, or I can get DNE. So I cannot draw a conclusion before I check. The top is positive. Can you please give me a number from the left of 5? Tiny, very close, I meant to say. Very close to 5 from the left. A number close to 5 from the left of 5.
Minus 10?
From the left of 5. So here's 5. I need a number from the left of 5 and then a number later on from the
4.9.
4.9. Excellent. 4.9 minus 5. What sign does 4.9 minus 5 have?
0.1.
It's sign.
It's a negative.
Negative. So positive over negative will be which of these?
Negative.
That's it. Now please give me a number from the right of 5, like 5.1, and tell me the sign of the denominator. Because the numerator is always positive, around 5.
Positive.
Good. And what do I write here? Which of these do I write here?
Infinity.
That's it. What does this mean? It means that x equals 5 is a vertical asymptote. What does that mean? I found something. I found something. I found something. Back, immediately back to the chart. Every time I find something in the chart, it has to end up there immediately, so I don't forget. What does this mean? It means that at x equals 5, the function from the left will go to negative infinity, something like this. And from the right will go to positive infinity, something like this. Because that's what this says. From the right-hand side of 5, the function will go to infinity. From the left-hand side of 5, the function will go to negative infinity. So as you see, 2 pages of work just to find the horizontal asymptote, x equals 5 vertical asymptote, and these limits, the y-intercept and the x-intercept. 2 pages. Where do I look when I want to graph? Only here. Because I summarized all my information in here. It's waiting for me. But I'm not ready to graph because I have to work on this and I have to work on this. So now I'm ready to continue with the first derivative. Okay. Which page am I on? I'm on 5. Good. So f of x equals 2x minus 3 over x minus 5. Now I'm ready to find f prime. Let me ask you this before you tell me what to do next. Whenever a rational function is undefined, it can have a hole in the graph or it can have a vertical asymptote. So potentially, if the function is never undefined, it will not have a vertical asymptote. If it has a vertical asymptote, if it's undefined, it can have vertical asymptote or have a hole in the graph. We're going to look at that in a next step. for a different function, not for this one, of course. Okay, so I know that this is the quotient rule. I have to use the quotient rule. I have to square the denominator. The numerator prime is how much?
2.
Very good. Times x minus 5 minus the numerator. How much is the denominator prime?
1.
1. Excellent. Always fully simplify this, because without critical numbers we can draw a conclusion if there are critical numbers. So I have 2x minus 10 minus 2x and plus 3. So this is negative 7 over x minus 5 squared. What about critical numbers? F prime of x equals 0 and f prime of x equals undefined. Let's start with this. Is this function ever undefined?
Yes.
When?
When denominator is 0.
Yeah, excellent. But so is the function. So no critical number. No critical number. Because it's undefined at 5, but so is the function. If it's a critical number, it is undefined, but the function exists there, but the function does not. Good. What about f prime of x equals 0? When can this function be 0? It's a fraction. When is a fraction 0?
And the numerator is 0?
Can the numerator be 0?
Nope.
Nope. So then I know for sure no critical numbers. No max, no min. If there are no critical numbers, no max, no min. Good. Can anyone tell us the sign of this expression forever? What is the sign of negative 7 over x minus 5 squared?
Negative.
Always negative. How come? Why is this always negative?
Because it's negative function.
Because this quantity is always what type? It's a quantity squared, so what type of sign can this have? What is it?
Something positive.
Yes, if this is always positive and there is a negative 7 at the top, obviously this will always be negative. Awesome. I found something. I found something. Put in the table immediately. I found that the first derivative never changes sign. It doesn't have critical numbers. And the sign is always negative. At this moment, I'm checking whether these two work well together. If they don't, I'll say oops and start from scratch. So let's see. So from 2 to 0.6, what does the function do from 2 to 0.6?
Decrease.
Is that supported by the sign of the derivative?
Yeah.
Perfect. From 0.6 to 0, you got the drift. From 0 to negative infinity, yes. From infinity to 2, yes. These two work well together. The function is always decreasing because the first derivative is always negative, and my numbers show that. From 2 down to 0.6, down to 0, down to negative infinity. On the other side, from positive infinity down to 2, always decreasing. Yes. Now I'm going to look at the second derivative. I'm going to change that so I can differentiate faster and easier. Good. Can anyone help us with the second derivative of this? (14). Yes.
14.
X minus 5 to the
Negative 1.
yeah,
Oh.
negative 2 minus 1, negative 3. times the inner function prime. We can never ever forget that. Times the inner function prime, which is
1.
that's it. So this is 14 over x minus 5 to the third power. Imagine that you rewrite this, or just rewrite it, as x minus 5 squared times x minus 5. Just imagine that. And you can ask, why? Why would I do this? And then I will ask you, what is the sign of this expression?
Of which one?
This one. Just this one. Just this p.
The squared is positive, right?
Good. What is the sign of the numerator?
Positive.
Good. So this will not affect the sign, because this is never 0 and never undefined, the same situation with the first derivative. So now I have to study the sign. So this is positive, this piece is positive, this is the only one that can change the sign. So I'm not going to worry about this. I'm not going to worry about this. I'm only going to worry about x minus 5 that gives the sign. So imagine only in x minus 5, to the left of 5, give me the sign. To the right of 5, give me the sign. Plug in any number to the left of 5 and tell me the sign, and any number to the right of 5 and tell me the sign. And I will put it in.
From the left, it's negative, and then from the right, it's positive.
Which means, awesome, thank you. Remember, a negative second derivative means the graph looks like this. A positive second derivative, the graph holds water, so to speak. I filled up the chart. The chart is filled up. I'm not going to need all these. Now this is gibberish. I don't care. This tells me what to graph. Nothing else matters at this point. I did my work. I filled up the chart. The chart tells me how to graph. And I think I'm on page 6, yeah. When I graph a function with asymptotes, I have to graph the asymptotes first. They are not part of the graph. They cannot be solid lines, but they have to be graphed first. Then I plot the ordered pairs. 0, 3, 5. 1.5, 0. And all I need to do is just follow the patterns here. It's coming from 2, opening down, and decreasing to the y-intercept. Okay. Continues to decrease, crosses the x-axis, going towards negative infinity, continues to decrease, continues to open down. It doesn't have corners, it's a smooth continuous function. On the other side, coming from the positive infinity, decreasing, opening up towards 2. This is the graph of 2x minus 3 over x minus 5. Without all my summary, without all the table that I have here, I would not be able to graph correctly.